So now I'm just going to introduce you to current thinking about the neural circuitry of fear and how these different kinds of fear, whether it be pain, fear of predators, fear of aggression, how they funnel through the brain through the amygdala and other areas to result in an appropriate behavior. So, for example, the appropriate behavior in the fear of pain model, that is looking at foot shock and classical conditioning, that behavior is different than the fear of predator or of a predator, or the fear of being aggressed upon by another animal of your own species. So there's these subtle differences on how this information works its way through these different brain areas, and that's what we're going to first talk about, and then we'll get to this, the fear of aggression, which is going to elaborate on that circuitry a little bit more, and then finally down here, this whole issue of this parasite, Toxoplasma gondii, and how it can take over the amygdala and kind of redirect these circuits so that what should be a defensive response now becomes something that's more like an approach response. Okay, so in any event, let's just talk about this neural circuitry of fear in general terms. So over here is what we already presented, and this is the low road, the high road idea. The idea that potentially threatening stimuli come in through a sensory organ. This would be visual or auditory. Okay, there's a different system for the odor stuff, but goes into the amygdala. If it's visual, if it's auditory, it's going to go into the lateral nucleus, to the central nucleus, and then goes to the central gray, or as I have down here, the periaqueductal gray. That's going to result in the behavior. We have the hypothalamus. It's going to have some autonomic responses as well as hormonal responses. But as we're going to see in this part here, the hypothalamus is also involved. Okay, and that's what I'm showing over here. So what this is showing is parallel downstream pathways. So we start in the amygdala, and as we're going to see, different parts of the amygdala receive different kinds of threat information. From there, it's going to go into the hypothalamus, from there to the periaqueductal gray, or PAG, and that is going to result in an appropriate behavior for the threat. So there's multiple pathways that are working through here. There's different parts of the amygdala that are going to receive this different information. That's going to go to different parts of the hypothalamus, and then to different parts of the PAG, although we're not going to go into that. But it's all these think of parallel pathways working their way down to the appropriate behavior. Okay, so this is one way of looking at it, and a lot of this came from the writings and the research of Newton Contreras, who's from, I think it's the University of Sao Paulo in Brazil, and he's done most of this mapping work where he's taken these different kinds of fears and mapped them in the brain. So we can think of these three regions as kind of modules. So we have an amygdala module, we have a hypothalamic module, and we have this PAG module. And how the threats make their way through here depends on the nature of the threat and the nature of the stimulus. So fear of pain, for example, this would be auditory generally, could be visual, but it's either auditory or visual. That information goes to the lateral nucleus first. That's the cortical structure within the amygdala. From there, it goes to the central amygdala, which is part of the which is a striatal portion of the amygdala, so I have them color coded in that way. This completely bypasses the ventromedial hypothalamus. Okay, it doesn't even go near it. It goes straight from the central amygdala to the periaqueductal gray. So let's go back to this one, and that's sort of where this is coming from. Okay, so I said that there would be a little bit of a hypothalamic thing in there, but when it comes to the fear of pain, no, that's not happening. Okay, so that's it, and then you end up with fear conditioning related to that. Generally, that would be freezing. Now, when we go to fear of predator, there's several ways that information could get into the amygdala. It could be olfactory, and that's what we've been talking about: the smell of a cat, the smell of a predator, anything that can potentially eat that animal. That smell has been encoded in their brain, and it's an innate fear. So that information goes directly from the olfactory system, and in particular the accessory olfactory system, that is the vomeronasal organ, the system that deals with pheromones. That goes from there directly to the medial amygdala, which is part of that striatal complex. And I probably should have put it in here, but if you go back to the stuff we did on Tuesday, the basics of the amygdala, you'll notice we had the lateral and the central as one component, and then down off to the lower left on that slide was the medial amygdala, and that's where that smell is coming in. Now from there, it goes into the VMH, which is the ventral medial hypothalamus. And it just occurred to me I probably should type that out, which I will on the slide that you're going to have. Ventromedial hypothalamus. And from there, it goes to the periaqueductal gray, where you have the defensive responses, which would be, hide first, try to hide. If that doesn't work, you freeze. If that doesn't work, then you attack. Okay? So the response. If the information is visual, okay, in the first example where I gave, the Blanchard's work, where they had the visible burrow system, and in that case, they put the cat in the cage. Now, the rat would smell the cat, but you also have that visual information as well. That information would go into the lateral nucleus of the amygdala, and then from there, it actually bypasses the striatal complex, doesn't go to the central nucleus, but goes straight from the lateral nucleus of the amygdala over to the ventromedial hypothalamus, the same region that this is feeding into, and goes to the PAG, where you get the defensive response. Okay? So, as you can see then, depending on the nature of the threat, depending upon the type of stimulus of the threat associated with the threat, it's going to course through this system, this fear system, this defensive system differently. But the end result is it's going to produce some kind of a response, some kind of a defensive response to the predator. In this case, you're also just going to get fear conditioning to painful stimuli. Okay? Okay, so that's the basic fear of predator compared to fear of pain, how it works its way through these two systems. Okay, whoa. Okay, I think we're going to hold off on this. That was weird. Okay, so that's going to be it for the pre-recorded part. This whole slide show is going to be all in one piece. And in class on Thursday, we'll continue this, focusing on adding to this, adding fear of aggression to this, and then we'll go into the parasite thing.